Okay, and this rolls 3 fair 6-sided dice yielding ABC, and we want to find the expected value of this sum. So, since we roll a fair dice and then getting A, B, and C are equally likely, for that reason, and A minus B and B minus C and C minus A are symmetric, so we can actually find the expected value of only one of these and multiply by 3 to make it a bit easier. So in that case, I'm going to choose like A could be at least 1. So let's say it's smaller than B, and B is at most 6. And it doesn't matter, so we can just swap this, which is going to be twice as much when we list this one. But when we do this, like when you actually ignore these two, when you just take a look at only 2 variables, you cannot really have 3 dice, you just have only 2 dice, right? So basically, I'm just changing the question to make it a bit easier, which is, this is called visual thinking, so it might be useful now. So what we are going to do now, we are going to kind of make a organization. So let's organize our counting. So if I have something like this, right? So the first thing I'm going to do is a difference. Okay, and then this is going to be outcomes. And then this is going to be the expected value. So, or the value of the expectation, whatever you call. Okay, so the first thing we can get, like you can get 1 for A and B as 6. The difference is like 5, or 6 and 1, which is like -5. But since this is absolute value, it will be no big deal. So I'm going to choose difference of 5, and then I will just write 1 and 6, which is one basically way that we can get. I can swap this, but I'm going to double at the end, so to make less writing. And for this expectation, we have only one outcome, right? So, and then we have only a difference of 5. So which is going to be 1 times 5 is our expected value of this outcome. And the second one, if I want to get the difference of 4, so I can get 1, 5, or 2, 6. And then we have 2 different outcomes, right? So, and then each outcome has a value of 4. So expected value of that is going to be 2 times 4. And if I want to get the difference of 3, so I can have 1, 4, like 2, 5, and then 3, 6, right? So which is we have 3 outcomes, and then their values is also 3. So that should be expected value. And if I want to get difference of 4, so I can get the 5, actually difference of 2. Okay. So then I could have 1, 3, like 2, 4, right? So 3, 5, and 4, 6. You don't have to list as long as you know what you are doing, so you can actually count those, which is 4 of these. So that will be just 4 times 2. And the last one is 1. So you can see that that will be 1, 2, all the way to the 5, 6. So which is 5 of them. So 5 times 1. So let's add these. So that's 5, that's 8, that's 9, 8, and 5. If you combine these, that's 10, 18, right, 26, and 35. So we have total of 35 outcome, right? So as expected value. So this is the expected I guess result. But the question now, we have to double this because we just didn't write the swapping those A and B's, because that will give us the same difference. So we should multiply this by 2. And at the beginning, I made this 2 dice and then with only A minus B. Now what we had only 3. So we are going to multiply this by 3, okay, just to get the final answer. But maybe we should multiply this at the end, not now. So when you multiply this by 2, you just did the expected value of the difference. So if you want to find the expected value, we have to divide this by the total outcome, right? Since every time you have 6 options for each dice, so since you have 2 dices, so that could be done 6 times 6 ways. That will be 36 outcome. This is the expected value of the getting A minus B. Okay, so now we can just multiply this by 3 to get the sum of those three. So then these guys will cancel. So you should get 35 over 6. So I hope that was clear. So if you kind of didn't like this one, you can try all three variables, which is going to take a bit longer. But what I'm going to do now, I'm going to make this question actually general, because that is actually way better in general, but I wouldn't do this on the test because it's going to take a while for some individuals. So if I clean this and put it back, okay, so I kind of use the same table so I can kind of see the relation. So instead of having 3, I'm going to have n of these dices, and I'll just use the same question, okay? So what I'm going to do now, the same thing. I'm going to cross these guys, and then I will just do the question for only a minus b, and at the end, I'm going to multiply that by 3, okay? So if I want to get the difference in the previous problem was 5, 6, and whatever, because there was like 6 faces. But if I have a, like, actually, I cannot do this, and this has to be 3, and then n has to be this. Okay, so if I have 3 n-sided dice, so it could be some number of sides basically, and I can just use the same thing. But since we changed the 2 variables, I'm going to make this 2, and then I will change this at the end to 3 by multiplying. Okay, so if I have n-sided dice, and the difference could be n minus 1, because in the first problem it was 6, and the difference was 5. So we can choose 1 and n, so difference will be n minus 1. So let's say this is n minus 1. But there is only one way to achieve this, which is 1 comma n, right? So that is something. So, and then this is going to be 1 times n minus 1, because we have only one pair. We are going to double this at the end again. If I want to get the difference of n minus 2, which you can pair those just to make sure, you can have 1 and n, and 2 and n minus 1. So whatever that n is. So we have 2 different pairs. So I can just list right here. So 1 and n, and 2n minus 1. So since we have 2 of these, I will just say 2 times n minus 2. And if you keep doing this, like n minus 3 will be like the previous, like we just got it. So you will get 3 of those times n minus 3. And if I want to do the last one, which is going to be, I cannot have the difference of n because 1 and n is the 2 farthest away numbers. So the difference could be at least 1, right? So, and then there will be only one example, which is 1 and like n, right? So, I mean, n, 1 and, no, difference of 1 will be n of these actually. So there will be n different result. I mean, n minus 1 result, not n, because you can just pair n minus 1 times. So I hope that was clear. So n minus 1 times. So the sum will be 1 times n minus 1 times 1. So I can just maybe swap these. N minus 1 times 1. So, okay, it does not look fun so far, right? So maybe we can try adding these guys. So if I want to kind of rewrite it a bit differently, so the first thing I can just do 1 times n minus 1 plus 2 times n minus 2. And then you just have 3 times n minus 3. And you will just keep doing this all the way to the last one, which is n minus 1 times 1. So we may try adding these in a way that we can kind of combine together. So we have 1n, 2n, 3n all the way to the n. And then minus 1, minus 4 and stuff. You can try adding those as well. But I just want to make a nice identity. That's why I'm going to write in a way that will be creating that identity. So if you just take the number of ones, just imagine there is like n minus 1 of ones, right? So which means if I list these numbers, like we have n minus 1 of these ones, and then n minus 2 of these twos. So if you want to pair these, like you will get something like this, 1 plus like a bunch of ones, but this number of ones is going to be n minus 1. Okay, n minus 1 of these ones. And the same thing with the 2. So 2 all the way to the last 2. And then that will be n minus 2 of these 2s. And if I keep doing this for 3s, I can do that. And the last ones will be, there's only one number that is like n minus 1. So you will just say n minus 1. I hope that was certainly clear. So now I'm going to rewrite this a bit differently. So if I want to kind of take this 1, because there is one more 1 compared to 2s, right? So I can just write that alone. And then if I take this 1 and then combine with this, I will just get 1 plus 2. And then if I take another 1 and then second 2, so from this, and then you get the first 3, so you will get 1 plus 2 plus 3. And if you keep doing this, the next one will be another 1, another 2, another 3. So you will keep doing this 1, 2, 3, and the next one will be 1 plus 2 plus like 3 plus 4. And since we have always one more number on this list than this list, or one more twos from the 3s, so it will continue all the way to the end, taking this. And for the last one, we have only no numbers like left to pair with this guy with the previous one. So the last number we should have is n minus 1. So make sure you really convince yourself before you move on to the next step. So now I'll think about these separately, because that was the whole point. That's why I just rewrite these in a way that will give us something. And then this is just 1, but another way of saying this, 2 choose 2, because that's, we can say. And then this is 1 plus 2, which is 3. But we say this is 3 choose 2 as well, because 3 choose 2 means 3 times 2 over 3 times 2 over 2. So that will be just 3. And the next one is 4 choose 2. Okay, and then the next one is 5 choose 2. And the last one should be, this one is n choose 2, right? Okay, so this is n choose 2. And we want to get these together, right? So, but how this is going to be? Like, I think I missed something right here, so I should fix that. So the last one is going to be, this guy would be when you combine these guys. So we have like 1, 2, all the way to this guy. So let's keep this in mind. So, and if you are not convinced with this, like choose any concrete numbers and kind of place into this expression, see if that's really the case. So now we got this n minus 1 and that last term. So if I just fix this one here, so you will get 1, 2, 3 all the way to n minus 1, which is n choose 2. So you can just use that. And now like we have this guy, but the numbers are always 2, and then the top numbers are increasing by 1. And if you remember the hockey stick identity, this is the same as one more of this guy, right? Which is going to be n plus 1. And then one more of this guy, which is choose 3. And we can just expand this guy, which will be n plus 1 times n minus 1. And then divided by 3 times 2 times 1, which is 6. So this is now our expected value of these sums, right? But we make sure we remember that we chose these like without really swapping these pairs. So which is why I should now multiply this by 2. Okay, so that's the case. And also we know we have 2 fair dice because we are doing just this much. And then we want to divide this guy by the like 6 squared, because every time you n squared, because we have only n side, which we don't know the number of sides for the dice, which is going to be n outcome for each dice, since we have only 2, which is going to be n times n. So we have to multiply this by 1 over n squared. And now this is going to tell us the expected value of a minus b. Now we can multiply this whole thing by 3 to get the expected value of the general expression when you have n-sided dice with 3 variables. Okay, so when I add this 3, make sure you remove this 2 from the problem, because that's the actual question that we just did. We just made it a bit easier. So let's clean this mess. So these will cancel. And then you got these guys will cancel. So then n plus 1, n minus 1 over n. Okay, so I hope I did not miss anything. So let's see, we had 6, 2. Okay, I think that's good. So now we got a general expression for the question that we have. And then since now this is the value of n is 6, so let's actually go ahead and plug and see if our answer was really correct. So that should give us 6 plus 1 is 7. 6 minus 1 is 5, so over 6, which is 35 over 6. So as you see, we kind of did a bit much work, but I wouldn't do this on the test for sure, but at least it is good to explore more when you have time. And also another reminder is, if this question was asked now, as kind of simple version of the problem, maybe in the future, they may be asking this a bit fancy way. Maybe we can include one more variable. So if you add A, B, C, D, then there's no really changes. So you can always use the same approach. So which is why it is good to explore more in depth. So I hope that was clear. I'll see you in the next video.